Welcome to Ask and Learn.
We want to find the ninth derivative of the function x to the 8th power times natural log of x. I'm going to call this function f of x. Okay, and for this problem we will use the product rule, which I've written here, the power rule, and just the rule for getting the derivative of the natural logarithm. Okay, so let's start by finding the first derivative of f. We have df dx is equal to, now using the product rule, I'm going to hold x to the 8th power constant and take the derivative of natural log of x. So the derivative of natural log of x is just 1 over x. Okay, and now I need to add the derivative of x to the 8th power, which I get using the power rule. So this is 8 times x to the 7th power, and I multiply it by natural log of x. And I can simplify this a little bit to get x to the 8th power divided by x is just x to the 7th power. And I can factor that out to have 1 plus 8 times natural log of x. Next, I will take the second derivative. Okay, so I get that by just taking the derivative of the first derivative. So we have, again, we're using the product rule, so I hold x to the 7th power constant, and I take the derivative of 1 plus 8 times natural log of x. So 1 is just a constant, so its derivative is 0. And then we have 8 times the derivative of natural log of x, which is 1 over x. Okay, and now I'm going to take the derivative of x to the 7th power. This is 7 times x to the 6th power. And then multiply by 1 plus 8 natural log of x. And I'm just going to simplify this a little bit. I have 8 times x to the 6th power plus 7 x to the 6th power times 1 plus 8 natural log of x. And I factor out x to the 6th power to get 8 plus 7 times 1 plus 8 natural log x. And this is 8 to the 6th power times 8 plus 7 is 15, plus 7 times 8 is 56, and then I have natural log of x. Okay, now I'll take the third derivative of f. So we have x to the 6th power times 56 over x plus 6 times x to the 5th power times 15 plus 56 times natural log of x. And so this simplifies to 56 times x to the 5th power plus 6x to the 5th power times 15 plus 56 natural log of x. And this is x to the 5th power times 56 plus 90, which is 146, plus 6 times 56, which is 336, times natural log of x. Now I'll take the fourth derivative of f. This is equal to x to the 5th times 336 divided by x plus 5x to the 4th times 146 plus 336 natural log x. So we have 336 times x to the 4th plus 5x to the 4th times 146 plus 336 natural log x. And I'm just going to leave it like that. And I'll take the fifth derivative. So we have 4 times 336 times x cubed plus 5x to the 4th times 336 divided by x plus 20x cubed times 146 plus 336 natural log x. So we have 4 times 336 plus 5 times 336 times x cubed plus 20x cubed times 146 plus 336 natural log x. And 4 plus 5 is 9, so this is just 9 times 336. Okay, so now let's take the sixth derivative. We have 3 times 9 times 336 times x squared plus 20x cubed times 336 divided by x plus 60x squared times 146 plus 336 natural log x. So we have, okay, these terms are both terms of x squared. And then we have, this is 27, and this is 20, so 27 plus 20 is 47. So we have 47 times 336 x squared plus 60x squared times 146 plus 336 natural log x. And taking the seventh derivative, we have 2 times 47 times 336x plus 60 x squared times 336 divided by x plus 120x times 146 plus 336 natural log x. Okay, so 2 times 47 is 94, plus 60 is 154. So we have 154 times 336 times x plus 120x times 146 plus 336 natural log x. Okay, let's take the eighth derivative now. This is equal to 154 times 336 plus 120x times 336 divided by x plus 120 times 146 plus 336 natural log of x. And I'm going to make some more space. So continuing up here, we have that the eighth derivative is 154 plus 120 is 274. So that's 274 times 336, okay, plus 120 times 146 plus 336 natural log of x. And I'll just erase this down here. So we can take the ninth derivative of f. So this is equal to, okay, this term here is a constant, so its derivative is 0. And then we have 120 times 336 divided by x. And this is equal to 4,320 divided by x, which is the same as 8 factorial divided by x. So this is our derivative. Another way to have solved this is we could have stopped at the third derivative and looked for a pattern. So I'm going to make some space here. So we have that the nth derivative of f, is equal to, okay, so I see that we have a factor of x to the fifth power in our third derivative. So that's x to the 8 minus n power. And then we have 56. Okay, so this is 8 times 7 times ... times 8 minus n minus 2. Okay, and we have plus 6. So this is plus 8 minus n minus 1. And that's multiplied by 15, which is 8 plus 7. So we have multiplied by 8 plus 7 plus ... plus 8 minus n minus 2. And then we have plus 6. Okay, so that's plus 8 minus n minus 2 multiplied by 56. Okay, so this is multiplied by, that's the same as this factor here, so I'll just repeat that. 8 times 7 times ... times 8 minus n minus 2. Okay, and that's multiplied by natural log of x. And that's everything. So now let's use this formula to find the 9th derivative. Okay, we have x to the 8 minus 9 power. 8 minus 9 is negative 1. Okay, multiplied by 8 times 7 times ... times... Okay, now let's look here. We have 9 minus 2, that's 7. So 8 minus 7 is 1. Okay, and then we add 9 minus 1 is 8, so 8 minus 8 is 0. So this entire term here is 0. Okay, and then we have 9 minus 2, which is 7. So 8 minus 7 is 1. We have 1 multiplied by this factor here, which we already found, is 8 times 7 times ... times 1 multiplied by natural log of x. And I'm sorry, I made a small mistake here. Okay, since this was supposed to be 6 times 56, so this is the 6th here when n is 3. So that means that this needs to be n minus 1. Okay, so then we would have 3 minus 1 is 2, and 8 minus 2 is 6, okay, which is what we wanted. So I'll just erase this, okay, and we'll redo it. So we have 9 minus 1 is 8, and 8 minus 8 is 0. So this term is also 0. And we are left with x to the negative 1 times, this factor here is just 8 factorial. Okay, so this is 8 factorial over x. Okay, so this is the same. So if you see a pattern, you can shorten your calculation by writing out a formula and then just subbing in the number of derivative that you need.